Welcome to This Explainer. I am absolutely thrilled to have you here today because we're looking into something that is quite literally the foundation of our modern world. When you walk past a construction site and see those massive cement mixer trucks, it's so easy to just think they pour the gray sludge, wait for it to dry, and call it a day. But the truth is actually way more fascinating. Before a single drop of concrete is committed to a structure, it has to pass a high-stakes recipe test for structural integrity. So today, we're exploring the concrete slump test, a quick, incredibly reliable field method to ensure that what we're building today will actually stand up to the extreme demands of tomorrow.
Okay, let's dive into this. Here is our exact roadmap for today. First, we'll cover workability and why it matters. Second, the equipment for the test. Third, the 5-step procedure. Fourth, diagnosing slump types. Fifth, typical slump ranges. And finally, number 6, best practices for reliability.
Starting right off with Section 1, workability and why it matters. Fresh concrete might look simple to the untrained eye, but there's a real hidden science to it. So how do we actually know concrete won't fail before it even dries? Well, it all comes down to consistency. Consistency completely dictates whether a building stands the test of time or becomes a massive structural liability. If the mix is off, it just won't settle right, it won't compact right, and it certainly won't perform right. And that perfectly brings us to our core concept, workability, which is often just called consistency. Simply put, it's the measure of how easily fresh concrete can be placed and compacted to meet very specific project specifications for performance. Think of it kind of like baking a cake, right? If your batter is too thick and dry, it just won't spread into the pan. But if it's too wet and soupy, it won't bake with a proper structure. The slump test tells us if our concrete batter is just right before it ever goes into the proverbial oven.
Let's move right along to Section 2, equipment for the test.
Just like a master chef meticulously organizing their mise en place before the dinner rush, a field worker needs a highly specific toolkit. You can't just use any old bucket and stick you find lying around the job site. You need a slump cone that is exactly 300 millimeters high, a tamping rod, specifically 16 millimeters in diameter and 600 millimeters long. You also need a perfectly level, non-absorbent base plate, a ruler, a scoop, and a stopwatch. Precision here is completely non-negotiable. Okay, let's move to and see how this builds. Section 3, the 5-step procedure. This is really the climax of our process. Out in the field, this procedure is a brisk, highly choreographed sequence. Step 1, fill the cone in 3 equal layers on that base plate. Step 2, rod each layer to ensure it's fully packed. Step 3, strike off the top layer so it's perfectly level. Step 4, lift the cone. And Step 5, measure the difference between the cone's original height and the highest point of the slumped concrete. Now within that sequence, there is a magic number, and that number is 25. During Step 2, you absolutely must rod each of those 3 layers exactly 25 times uniformly with the tamping rod. And here is the trick. You have to penetrate slightly into the previous layer as you go. This meticulous rodding ensures proper compaction and guarantees there are no hidden air pockets throwing off your results. Then we get to the most suspenseful part of the test, the lift. Notice the specific guidance. You must lift that cone straight up, vertically, in exactly 5 to 10 seconds. You need a remarkably steady hand for this. Any twisting, any sideways motion at all completely ruins the high-stakes test. It requires absolute, total focus to pull this off flawlessly on a busy, chaotic site. And the pressure is really on here because the entire test must be completed within 2.5 minutes after sampling. Fresh concrete waits for literally no one. It is a highly time-sensitive material, and dragging out the test will just result in a false reading as the concrete naturally begins to stiffen. You have exactly 150 seconds to sample, fill, rod, strike, lift, and measure. Which brings us to the resolution phase, Section 4, diagnosing slump types. The tension breaks, and we analyze the bake. Now, what's really interesting about this breakdown is how field workers instantly diagnose the structural integrity based on just 3 visual cues. If you get uniform subsidence, that's a true slump, indicating good workability. If it shears off sideways, that is a shear slump, meaning it's not a true slump, and you have to repeat the test. Finally, if the concrete collapses completely into a puddle, that's a collapsed slump. The verdict? The mix is way too wet and is strictly not acceptable. Let's clearly contrast these 2 extremes. A true slump shows a mix that subsides uniformly but still maintains its structural character, proving it's ready for placement. On the other hand, a collapsed slump looks like a sad, deflated pancake.
The mix is so incredibly wet it can't even hold its own weight. Pumping that into a foundation would be an absolute disaster. Section 5, typical slump ranges. This is where we translate that visual slump into hard, actionable numbers. When we perform step 5, measuring the height difference, we get a measurement in millimeters. 0 to 25 millimeters means dry or low workability, which is often required for heavy-duty foundations. 25 to 75 gives you medium workability. 75 to 150 is high workability. And if you are using high-flow or pumped concrete, you want a massive slump range of 150 to 200 millimeters. To put that into perspective, a 25 millimeter measurement means something entirely different than a 150 millimeter one, totally depending on the application. Finally, Section 6, best practices for reliability. Let's look at how we ensure these field tests are foolproof every single time. So, the crucial point is that a test is only as good as the conditions under which it's performed. Good practice dictates you must always ensure your equipment is clean and damp before starting, so the concrete doesn't stick. You must perform the test on a perfectly level surface. You absolutely must beat that 2.5-minute clock. And lastly, you must formally record the slump measurement alongside any visual observations. These are simple but vital rules for quality assurance. This entire meticulous process is perfectly summarized by one core philosophy: consistency today, strength tomorrow. The slump test isn't just busy work. It's the absolute frontline defense for delivering concrete that stands the test of time and creates structures that will last for generations. Tested, verified, trusted. It really changes how you look at the built environment around you, doesn't it? Next time you walk past a construction site and see a high-rise being poured, will you wonder if their concrete passed that intense 2.5-minute slump test? Thank you so much for joining me for this explainer. Keep wondering, keep observing, and I'll catch you next time.